All right, so now let's look at problem 3. Again, I don't know. Because I can't remember. I don't actually know if these fit any of our patterns. Let's see. I don't think so. We have the feedback going to Vn. It might be. Let's see. Yeah, it is actually. And I will let you go back and see if you can figure out how to do it, using the just recognizing it as one of those up there. So I'm not doing that. You can always do all problems just using the rules of ideal op amps. And so that's what we're going to do right now. So, what are our rules? Our rules are that IP has to equal IN has to equal 0. So IP has to equal IN has to equal 0. And the other one is that VP has to equal VN. All right, so if IP has to equal IN has to equal 0, then we have our current right here. IP is 0, so we have no current here. That means we also have to have no current here. So we have no current going into here, but since there is no current going through here, since there's no current there, then the voltage everywhere is the same. So we know that VP has to be 3 volts. Well, ideal op amps tell us that VN also has to be 3 volts. All right, so we know we have to have 3 volts right there. 3 volts right there. We know as well, if I call this VO right there, and I look at this stretch right there, I'll draw it like this. Okay, this is V out. This is RF. This is, I can label that as VN because it has to be VN because, so that's VN would be the voltage there. That's all VN. This is ground, and this is 4 kiloohms. Now, there is no current flowing in this part right here. So since there's no current flowing in this part right there, then I can look at the green part here and just use voltage division on it because there's no current going through that maroon part right there because IN has to be 0. So my total voltage drop or voltage change from here to here is VO, and VN is my point in the middle. So VN has to equal my entire voltage change times, now that would be the resistance here, which is 4 kiloohms, over the total resistance, which is 4 kiloohms, plus RF. And I believe it's RF that we're looking for. Yes, we're looking for RF. We're trying to find RF so that the current would deliver 75 milliwatts of power to RL. Okay, so we know VN has to be 3. So 3 has to equal V out times 4 kiloohms over 4 kiloohms plus RF. Now, so don't know yet, don't have enough yet to figure this out because I have my two unknowns there. But I do have this 75 milliwatts of power, and I can use that. So I know that power equals IV. And we are given in the problem that RL equals 3 kiloohms. So that's 3 kiloohms. So the current going this way, the current going that way, is our voltage. So our current is our voltage over our resistance. So our power, which is 75 milliwatts, or 0.075 watts, equals our current, which is VO over 3000, times our voltage. Well, our voltage is VO. So 3000 times 0.075 is 225, equals VO squared, or VO equals 15 volts. Well, now that I know what VO is, I can go back over to here, and I get 3 equals 15 times 4 kiloohms over 4 kiloohms plus RF. And I'll multiply both sides by 4 kiloohms plus RF and divide both sides by 3. So I get 4 kiloohms plus RF equals, and 15 divided by 3 is 5. 5 times 4 kiloohms is 20 kiloohms. Or RF equals 16 kiloohms. So I would ask, are there any questions? But nobody came to my SI session. So, no questions.